Welcome, everyone. I am super excited to dive into this explainer with you today. We are going to unpack a really fundamental shift in software engineering that's literally happening right under our fingertips as we speak. Basically, we're looking at how the modern terminal has evolved from being this passive, straightforward text input window into a massive, autonomous, multi-agent orchestration harness. It's a huge shift, and we're going to explore this whole concept through the lens of third-generation terminal agents. Specifically, we'll be looking at the Google Antigravity Command Line Interface, or CLI. Honestly, if you've ever felt like your coding workflow is just on the verge of hitting warp speed, this is exactly why.
Okay, let's just jump right in. We basically have to completely rewire how we think about a relationship with a command line. I mean, the old paradigm treated you, the developer, as a human syntax generator, right? You're just sitting there typing line by line, command by command. But this new reality, it's all about system-level orchestration. You're shifting away from that direct line-by-line code generation to something way more powerful, which is intent definition and architectural constraint specification. So you're now supervising these autonomous agents that can execute multi-step planning, parse entire directories, and actually iteratively refactor a codebase across these prolonged execution cycles. It's a total game changer.
Section 1. Navigating the TUI, the Operator's Command Center.
So, like we said, you're no longer just a typist. You are essentially a systems architect sitting in a high-speed command center. And that means you really need to master the physical mechanics of this space. To orchestrate these agents effectively, you need low-overhead, maximum-speed context switching. Your hands absolutely cannot leave the keyboard. The Antigravity TUI is built on this unified shared harness architecture, which basically means you get the sheer power of a desktop IDE right there in your terminal. And your core baseline navigation relies on three absolutely crucial hotkeys. Control-K instantly opens up your conversation picker, which lets you jump seamlessly between different agent threads. Control-P pulls up your file search so you can target context injections without missing a beat. And Control-L, that immediately focuses your input so you can fire off your very next command.
Picture your terminal keyboard just lighting up with kinetic energy. Control-K. Control-P, Control-L, boom, boom, boom. It's this fast-paced, totally fluid dance. You're effortlessly switching from conversation history over to file mapping and right back to issuing directives. This keyboard-driven workflow completely eliminates the friction of having to reach over for a mouse. It keeps your cognitive momentum entirely unbroken as you're dictating the agent's focus, literally at the speed of thought. Section 2. Framing and Intent Modeling, Shaping the Agent's Boundaries.
All right, moving on from those basic keyboard mechanics, let's talk about the strategic deployment of power/commands. This is where your human intent actually gets translated into strict constraints that an autonomous agent can reason against. And what's really fascinating here is this concept of adversarial pressure testing using the /grill me command. See, when you have a massive generative model at your disposal, the real danger isn't that it won't write code. The danger is that it'll write code based on your flawed or incomplete assumptions. So the /grill me routine completely flips the script. It's actually kind of wild. Instead of you prompting the AI aggressively interrogates you. It pressure tests your architecture to uncover missing edge cases and security vectors before a single line of syntax is ever generated.
Let's look at what that actually sounds like in practice. Imagine you ask the agent to migrate your authentication middleware and you trigger /grill me. The agent fires right back. What happens when the off middleware hits a race condition? Have you defined the JWT expiration limits? Do existing integration tests pass without modifying assertions? It actively forces you, the engineer, to clarify your intent declaratively. It demands that you establish those boundary conditions, mostly because the model cannot magically infer your unstated organizational security policies.
So the really crucial part is what happens after you survive that little interrogation and you lock in your intent. You deploy the /goal command. Now, the system doesn't just start aggressively overwriting your files right away. Instead, it triggers this continuous headless loop that's broken down into 4 distinct phases: observe, plan, act, and verify. First up is context assembly, where it establishes the baseline state. Second is artifact generation, where the agent actually produces an implementation plan for you to review. Third is tool invocation, which is applying the edits and running local scripts. And finally, verification, where it runs your test suites to validate mutations. If a test happens to fail, the agent just feeds that stock trace right back into its context and self-heals until it passes. It's taking your massive feature request and decomposing it into atomic, verifiable subgoals, completely without needing any human handholding.
Section 3. Orchestrating background agents. The /agents control panel.
But wait, what if your project is absolutely huge? What if one agent just isn't enough? Well, that's exactly where you elevate from being a standard developer to a distributed systems orchestrator. Because managing a massive codebase with just a single agent degrades performance due to context pollution. So you use hierarchical topologies instead. You bring up the /agents panel to spawn parallel sub-agents. You could literally have Agent A writing unit tests in the background, while Agent B is over there refactoring your API endpoints. And while they are running these heavy asynchronous compilation tasks, you can use the /btw command, which literally stands for, by the way, to issue quick side-channel queries. So you can ask a quick question without corrupting that primary context window or interrupting the main execution thread of those background workers.
Now, we have to be realistic here. Autonomous agents can sometimes get confused and enter these infinite failure loops, especially if they hit unexpected runtime errors. You absolutely need strict circuit breakers. And inside that interactive/agents panel, you have total supervisory control. If an agent starts hallucinating or gets stuck in a recursive failure loop, you just press K. That's it. Press K to instantly kill frozen execution threads. It is this immediate, high-impact circuit breaker that just halts the runaway process dead in its tracks, allowing you to restore your workspace to a clean, pre-prompt checkpoint. You are always the ultimate authority in the system.
Section 4. Visual proof and verification. Closing the loop deterministically.
So let's see how all of this builds into a fully reliable system. We've planned, we've executed across multiple agents, but at the end of the day, software production requires strict, deterministic outcomes. We actually have to prove the code works. AI-generated code is by definition untrusted input until it's verified. We talked about test-driven feedback loops earlier, but what about the front end? Well, we can actually utilize multimodal visual proof using the /browser command. What this does is invoke headless browser drivers to render your UI layout frames in real time. The agent takes screenshot comparisons to deterministically verify that its front-end code changes actually match the visual mockups and design specs you gave it. It beautifully closes the loop, proving that the agent didn't just write code that's syntactically correct, but code that visually achieves your exact architectural intent.
Wow. Okay, we've covered a ton of ground today. We looked at the lightning-fast keyboard navigation with Control K, P, and L. We explored the immense power of those / commands like goal, grill me, agents, and browser, and we saw how to kill runaway threads with a single keystroke. The tools are absolutely here, and the terminal has evolved. So I want to leave you with this final, somewhat provocative challenge based on everything we just unpacked. How must your engineering mindset shift now that you are a systems orchestrator and no longer just a typist? The core value of software engineering has officially migrated from generating syntax to defining architectural intent. The question is, are you ready to take command? Thank you so much for joining me on this explainer, and I highly encourage you to go out and explore these new terminal paradigms for yourself. Have a great one.